All right. And then we're going to just go through the list. So the first thing you see is domain, and what's the domain? Nope, follow this. What's the domain? All real. You actually can't see the domain on a polar graph because the input is theta, and theta is around, going around, so you can't see it. It's not like a domain and range of a regular function. What's the range going to be? So, well, tell me what A is. A is -4, the absolute value of A is 4, so when we do our range, it's going to be -4 to 4. Okay, so the next thing that we should state is that this is a continuous function. All right, so again, I'm following the things that I want you to analyze on here, okay? Let's take a look at symmetry. So, is n even or odd? It's even. So when n is even, no matter what kind of function, cosine or sine, this is going to have x-axis, y-axis. Origin just means rotation symmetry. Okay. Also, rose curves are bounded. Bless you. What's the next thing we should state? The max R value. And what is that? Yep, it's the absolute value of A, which is 4. And there are no asymptotes. And then how many petals? 4. And again, you can see that on the graph, but this is a case where n is even, and when n is an even number, n is the number in front, there are going to be double the amount of petals. That's 5, because 2 times 2 is 4. Okay, does that make sense? Okay. So those are rose curves. The second kind that we see are limacons. Now, a limacon is going to have a number, so that's my A, plus or minus B sine theta, or A plus or minus B cosine theta. So do you see how they're different than this? There's a number added in front. So what happens, though, is these limacons, there's different types. So there's a picture in your book, and then we're going to write on our note page so we have it, of the different types. So if you look on page 545, there are 4 different types of limacon curves. And hopefully their names make sense. This one is an inner loop, so you see it making an inner loop. And I'll tell you in a second, this is what we're going to write down when that happens. This is called a cardioid, so it almost makes, I know this part doesn't come to a tip, but like a heart shape. But it comes to a point there. This is dimpled because it comes in, but it's not coming to a point. And this is convex, so it just kind of flattens out. From geometry, do you remember what convex and non-convex meant? Okay, so convex means it's not caved in. Okay, these are, well, all 3 of those are caved in a little bit. Okay, but this one's convex because it just flattens out, it doesn't cave in. All right, so on our note sheet, you guys have this, right? Your note sheet with you. Let's write down the 4 different types. Okay, so let's start with inner loop. it's going to be an inner loop when you divide A over B, this A and this B. And by the way, those are always positive numbers. This plus or minus tells you that if it's addition or subtraction. So if you divide A over B and you get a number that is less than 1, that's going to be an inner loop. For a cardioid, that's the one that kind of looked heart-shaped. When you take A over B, it's going to be exactly equal to 1. When it's dimpled, A over B is going to be between 1 and 2. So it's greater than 1, less than 2. And the last one, convex, is when A over B is greater than or equal to 2. So when you're deciding your types, don't just look at them and try to guess. Use that, those ratios to do that. Okay, so let's take a look at a lemmathon in a minute. You guys have that written down. All right, so the one I would like us to look at is R equals 2 minus 3 cosine of theta. So before we even start, let's decide, we know it's a lemmathon, let's decide what type. So this is A and this is B. So A is 2 and B is 3. We get 2/3. So what kind is this going to be when we look? Good, it's going to be an inner loop, because it is a number less than 1. All right, let's take a look. Okay, so there it is. It's an inner loop. Let's take a look then. We're going to use our reference sheet to help us. What is the domain of this? All real. The range, and this is where, again, you can't see the range on the graph. It's not bottom to top because we're in polar mode. We're talking about what's the smallest R value, what's the largest R value. And so if you look here, and just keep in mind that A and B, we always treat them as positive numbers. Right here it tells you plus or minus, okay? So to find the range, we're going to do A minus B. 2 minus 3 is what? -1. And then we do A plus B. Yep. So the range is 5. Once again, this is a continuous function. Hello? No. Yeah, she is. Okay. using that today. Okay. Bye. Okay. What kind of symmetry does this have? I know you can see from the graph, probably, right? But also it says if this is a sine, it's y-axis. If this is a cosine, it's going to be x-axis. This is bounded. The maximum R value is A plus B, so what would that be? 5. And there are no F's.